All right. So right now we are looking at, all right, describing motion from a PT graph. So position versus time graph or a distance versus time graph. They're essentially the same thing. We're going to treat them the same exact way. So first thing we have object A, which is going to be this line here. So you guys mark that down. We have object B, which is the bold line. And then we have object C, and that is this kind of curved-ish line here. So it asks, how far did each of them travel? So B, go to the very end of the line, and then go to the left, to the y-axis, and you are at 60, okay? Let's look at letter A. Letter A, to the end of that, go up, go to the left until we hit the y-axis. You're at 60. Yep. Go to C. C, go to the end of that. Oh, snap. They're all at 60. So for number 1, 60. What is the unit? Well, let's look at the y-axis here. It says miles. So we're going to write 60 miles. Which object had the greatest average speed? Now, they didn't ask us to calculate it. We're supposed to be able to do this by numbers, all right, by kind of looking at it. Very simply, which letter, A, B, or C, finished in the shortest amount of time? Well, A finished in 60 hours. C finished in 40. B finished in 30. So the fastest speed would be B. The fastest was B because B finished in the shortest amount of time. And then who had the slowest? Yeah, A. A took the longest time. So we'd have this. Give me 1 second, guys. So when we're looking back at this, now they want to know the actual average speed of each of these. So what is the equation for average speed? It's the total distance divided by the total time. Well, we already said in number 1 that they all go 60 miles, but they all don't do it in the same amount of time. So for A, how long does it take A to finish this? 60 hours. So we have 60 miles over 60 hours. Throw that into your calculator. That's going to kick us out 1. And the unit will be the distance unit divided by the time unit. Most of the time, guys, we're going to be dealing with meters per second. But based off of just this, we're going to use the miles per hour. Letter B, 60 miles. And how many hours does B finish in? 40. So we're going 60 miles over 40 hours, and that comes out to be I was looking at C. Thank you for the heads up. B finishes in 30 hours, so we would be doing 60 over 30, which is 2 miles per hour. Thank you for catching that. And then finally, object C does its 60 miles in 40 hours. So we would have 60 over 40, and that would kick us out here an answer of 1.5 miles an hour. The next question asks, which object accelerated when it was in motion? Well, let's go back and look. A, did it ever change, or was that slope the same the whole time? So it's a constant velocity in the positive direction. B, never changed. It's a constant velocity in the positive direction. Let me ask you this, though. Who's faster, A or B? B. We can just tell straight up by the slope. The steeper it is, the faster it is. Sweet. So that leaves us with C. C is the only one where we have the kind of a curve going on. All right, so it started off slow, it moved faster, and then it moves its fastest in that point. So object that was in accelerated motion, we're going to say that was object C. What is the average velocity between 20 and 30 hours? So for this, the velocity, that equation we have up at the top I listed, is delta x over t. Delta x stands for displacement, which just means the final position minus your initial position over the time. So, okay, with that, how I like to say it is, where you are at 20 seconds Wherever you are at 20 seconds, that's going to be your initial position. Wherever you are at the 30 hours, sorry, not seconds, that's your final position. So let's run up, let's take a look. All right, we're looking at object C. So where are you at 20 hours? So at 20 hours, I go up until I hit the slope and go across. So I'm at 10. So I'm just going to fill in xi as 10. And then where are you at the 30 hours? Good. So you go to 30 hours, go up till you hit your slope, and go across. You are at 20. All right, and then the question some people were asking earlier, how do you figure out where t is? So t is the difference between the two times. 30 minus 20 is 10. So here's your equation, xf minus xi over t. xf was 20 minus xi of 10 divided by the time, and you're just going to take the difference in the time. So 30 minus 20 would be 10. And this just comes out to be 1. And since the unit we're dealing with is miles, and that's our distance unit, and the time unit is hours, we're going to go like that. All right, so now let's look at it between the hours of 30 and 40. So at 30 hours, we go up, go to 30, go up, and go across. You're at 20. So xi would be 20. And then they said the time of 40 hours as your second time. So go to 40, go up, and then go across. You're at 60. So we were initially at 20, final position 60. Let me zoom out. And cool, so xf minus xi, so 60 minus 20. And how long were you moving for? 40 minus 30 is 10. And this, when you type it into your calculator, is going to come out to be 4 miles per hour. And then finally, they want to know what it is between 58.
Yeah, 60 minus 20 divided by 10.
Well, 60 minus 20 is how much? Did you type it all in one way? Try to do it separate. Do the top part first. Do 60 minus 20, hit equals, and then divide by 10. Okay. What it probably did in those calculators, it probably did 20 divided by 10 is 2, and then 60 minus 2 would have been 58. That's probably why it kicked you out with that. All right, so in this case here, between 0 hours and 20 hours. So at 0 hours, line segment C was at 0, so your xi is 0. Where you are at 20 hours. For C, go up and hit across. You're at 10. All right, so now you have xi and xf. 10 minus 0. And then what is the time? The time is the difference between the top, like the first and the second time, right? So 20 minus 0. Now the time is 20 instead of 10. The first ones were 10 because 30 minus 20 is 10. 30 minus 40 was 10. But this time the time is 20 minus 0. And yes, so this is going to come out to be 10 divided by 20, or 0.5 miles per hour. Yep, you can start your pass. Okay, how are we doing with that? Any questions on that? No questions. Okay, so that means you guys are getting it. If you're not, this is fine. You got to ask questions, all right? But we got to make sure we're up and looking and listening, okay? So we can't have our heads down, gentlemen. Thank you. All right, so now what we're looking at is they want us to explain in words this time what the heck is going on over this point in time. So from our stuff yesterday and from the do now, slopes like lines 2, 3 and 5. Is there any curves to that?
3 and 5?
1, 3, and 5. Are there any curves?
No curve.
So that means those things are moving at a constant velocity on a position versus time graph. Where you're increasing your position at a constant rate. So that means you're basically going at a constant velocity, constant speed in this case, positive direction. Constant velocity in the positive direction. Number 5, line 5, is constant velocity in the negative direction. Flat lines, what do flat lines mean?
No.
Not moving. So what we're going to do is we're going to break this down. In line segment 1, you're going to write this, 1. Are you moving at a constant velocity in line segment 1?
Yes.
Is it positive or negative?
Positive.
So we're going to write positive constant velocity. Good. Line segment 2, are you moving? No, line segment 2, you're not moving. So we're going to say that you are
Still.
at rest. It's usually basically what we're saying when we're saying not moving. Line segment 3, is that a constant velocity?
Yes.
Yes, because it's not changing its speed at all.
So positive constant velocity.
Positive constant velocity. The only thing I'm going to say we're going to add to that, positive constant velocity, is line segment 3 faster or slower
Slower.
than 1?
Slower.
And I'm just going to write slower than line 1. What are we doing at part 4?
You're at rest.
Part 4, flat line. So at rest. And then at line segment 5, let me ask this. Are you moving at a constant velocity?
Yes.
Yes, but now is line segment 5, is it positive or negative?
Negative.
Negative. So we're going to write negative constant velocity.
Faster than 3. Should we write that too?
We could definitely say like it's faster than 3 or faster than. How about we just for this one we're going to write fast.
Fast as hell.
Yeah. All right, and how do I know? Well, it's steeper than 3 by a lot, and it's definitely steeper than 1 as well. So this one, when we calculate the velocity, right, 5 should have the fastest or the highest magnitude, right? It should be like the fastest velocity, fastest speed. Just for the units that I want to try and stay in meters per second here, we're just going to cross out the word minutes, guys,
Cross out the word minutes.
and replace that with seconds.
Got that going. You want math again? Let me write
All right, so now I left the equation for you guys for velocity in the top right-hand corner. So how this is going to work is there was no given time segments. There's no given like, from 0 seconds to 2 seconds or from 0 to 3. There weren't. All we have is when they're telling me find average velocity to number 1. So what we're going to do is you're going to break this down by line segments. All right, we're going from 1 to here. All right, this is all of line segment 1 before we have a different part of motion. So this is wherever you are here is going to be at the start of the line is xi. Wherever you are at the end of that line is going to be the xf, your final position. So for number 1, your xi, your initial position is 0 meters. Your xf, where you are at the end of line segment 1, how do you figure that out again? So you go to that end part of the line, all right, and then go to the left until you hit where you are on the y-axis. So we're at 100 meters.
Isn't that 50 meters per second?
Well, yes, considering we're doing it over this certain specific time. So how do you determine the time? Well, what was your time at the start of the line segment? It was 0. What is your time at the end of the line segment? You're at 2. 2 minus 0 is 2 seconds. So your t is 2 seconds. So I have xi, xf, and t. Remember that the equation that you guys are going to be using, all right, is for this, all right, velocity is your final position minus the initial position over the time. So we have that. Finals 100 minus 0 over 2, and this comes out to be 50. Now the distance unit that they gave us was meters, and I had you guys cross out minutes to use times. Just end that pass. And then, so you're going to have 50. That's not a good looking 0. Meters per second, and then box your answer.
Box it up.
All right. Now for velocity of 2. At the start of line segment 2, you're right here. At the end of line segment 2, you're also right here. So your xi is 100, where you are to start, and where you are at the end of line 2, we go across, we're still at 100. So both xi and xf are 100. And how long were you moving?
1 second.
You go from 2 seconds to 3 seconds. So 3 minus 2 is just 1 second.
Yep.
Okay, so according to our equation, you do xf minus xi, so 100 minus 100 over 1. It's going to be 0. And that should make sense because, yes, we should know just from our stuff from yesterday and the do now, that flat lines on a PT graph, position time graph, flat lines, you're not changing your position. So you're not moving any farther forward to the right, right? So like here, you're moving to the right 100 meters in 2 seconds. Now I'm not moving. I'm just kind of sitting. I'm moving a certain distance to the right, not moving. And then I turn around and I'm moving a certain distance to the left in a certain period of time. So we're going to look at the rest of those. Line segment 3. Okay, we need to know xi and xf. So what is your xi for line segment 3? Take here, good. Go across. Xi is 100. Kat, what'd you say the xf was for line segment 3? Very good, because line segment 3 ends here. We go across. We're at $1.50. How long were you moving though? You started at 3, and you finished this line segment at 6 seconds. So 6 minus 3 is 3 seconds. All right, again, we're throwing it into the equation here. So you're going to do 150 minus 100 over 3. And that should come out to be 16.6 repeating. We can round that to 2 decimals and get 16.67 meters per second. Very nice. Very nice. Looking good. Looking good. Line segment 4. We start at 150 and we end at 150. So we started at 150, we ended at 150. So for this one, xi, $1.50. Xf is also $1.50. How long were you moving for in that one? Let's go to line segment 4. You were moving from 6 minutes to, well, I'm right in the middle of 7 and 8. So what would that be? So what's 7.5 minus 6? Yeah, just 1.5. So your time is 1.5 seconds. Xf minus xi. That's cool. It's going to be 0. And then we're going to look at our next one. We're We're going to look at our next one. I want you guys to try this for a second. All right, and I want to see you guys solve for this one. I want to see you guys solve for number 5 really quickly. All right, so line segment 5 starts here at 150. That would be your XI. Your XF is 50. The time, the start of the line is at 7.5. The end of the line is at 8. Subtract those two. 8 minus 7.5 is 0.5. So now you have your times. All right, you have your XI is 150, XF 50, times 0.5. I saw a couple people go 150 minus 50 over the time, but you have to be careful. The equation says XF minus XI. So you have to take the 50 minus 150 and divide it by the time of 0.5. And when you do that in your calculator, you come out with negative 200 meters per second. Now for that works. And think about it again. When velocity, yes, you can have negative. Velocity, because the negative is indicating direction. This was positive, 0, positive, 0. This one changed direction, so that's why we have the negative on that. All right, now for 3 and 4, they say calculate the average speed of the entire trip. They say total distance. So the way I like to do this is break it down by line segments. Line segment 1, you went from 0 to 100. How far did you actually move? I'm going to write 100 meters above line segment 1. Line segment 2, you were at 100, you stayed at 100. Did you move?
No,
0. Line segment 3, you went from 100 to 150, so you moved a total distance there of 50 meters. Line segment 4, you were at 150, you stayed there, you didn't increase or decrease, so that is 0.
100.
And then line segment 5, you were at 150, and you came all the way back down to 50. So that difference is 100. Now, someone asked, do I put negative 100? Not for distance. Distance, we don't need to worry about direction. So how do you find the total distance? You just add all those up. So D would equal 100. I don't need to worry about the zeros, so plus 50 plus another 100. And the distance would be 250 meters.
We understand that?
Now, the equation at the bottom of your paper says total distance divided by the total time. What was our total time again?
8 seconds.
8 seconds. So in your calculators, you're going to write in that's the speed was equal to 250 meters over 8 seconds and 31.25 meters per second. So that's how you're going to do, all right, on the assignment tomorrow, on a quiz, when they ask you on a test, and they ask you to figure out the average speed of the whole thing. That's what you're going to need to be able to do. You're going to need to be able to break down, how do I find the distance traveled?
Drop them out.
All right. And that's probably the easiest way to do it, all right? And then the last one, average velocity, wrote displacement over time. What is displacement? Well, it's what we were just using. XF minus XI over T. All right. Well, let's see. What was the final position of the whole trip? Where are you at the very, very end? You're right here. Go across. So your XF for the whole trip is 50 meters. What was your initial position at the start of the trip? 0. So that would be that. And the time is still that 8 seconds. So XI was 0. And T was 8. So when you divide these out, you should come out with a 6.25 meters per second.
The entire trip or the whole trip or